Welcome. My name is Vincent Rijmen. I'm Program Director of the Master of Science in Electrical Engineering at KULeuven, and in this presentation I will tell you a bit more about our master program. First of all, I'm going to tell you what we mean by electrical engineering. So under this concept we understand the design of electrical and electronic systems, but not just the design of circuits and chips, but also the design of applications in a broad range of products, taking into account the specific demands and properties of software, hardware, and mathematical algorithms. So in other words, what we teach you is how to perform an integrated design, where you do not just stay at the level of circuits, or you do not just stay at the level of designing processors and architectures or algorithms or applications, but actually you go across all these levels. So starting from an application like image analysis, you will learn how to select a good algorithm that can solve the problem that you need to be solved, but you will not just go for the algorithm that is guaranteed to give you the best solution. No, you will also learn how to take into account, for example, the processors that you can choose between, the architectures and the properties of your circuits. And if your application, for example, has to run from a battery, you will learn how to select circuits that consume not too much energy, which processors are energy efficient, and which algorithms maybe can give you, for a little sacrifice in accuracy, a much better performance in energy consumption. And on the other hand, you will also learn how to design circuits that are in specific demand by novel processors that are optimized to run modern algorithms that are in demand in many modern applications. And as a first practical example, we see here a modern car. Modern cars are equipped with a lot of processors and electrical circuits in order to control the car and to optimize its performance. And in the courses of our master program, you will learn about several aspects that are important for these cars. For example, you will learn about, in the crypto course, about how to secure digital applications, which in a car are important to make sure that the car does not get stolen. You will learn the design of analog circuits and digital platforms for the various circuits that are of use in the car. You will learn how to design sensors. Cars use sensors not only to measure their internal affairs like fuel level, temperature of the engine, oil level, the quality of the combustion process, but they also have a lot of sensors that look at the outside world, cameras, but also radars, lidars, and all these signals are then combined, processed in order to tell the car whether there is a pedestrian in front, or whether there is an obstacle in front, or whether the road is going to curve, things like that. Cars also consume energy, so we also teach you about how to store energy in batteries, how to make the engine energy efficient. And finally, cars also need to entertain the users. You will also learn how multimedia works in a wide range of platforms, but also in cars. And I maybe should mention that in our department, the Department of Electrical Engineering, there is also a research group actively working to develop cars into fully autonomous vehicles. Another example is from by the smartphones. Smartphones have also sensors. Smartphones have different types of antennas, because with your smartphone you can connect to the GSM network, but also to the Wi-Fi network. There is a Bluetooth antenna in there. All these antennas have to be in this small form factor and should not interfere with one another. You will learn how to operate mobile networks such that when users roam around, they don't have to wait, they can seamlessly connect to a wide range of applications. Of course, there's a lot of signal and data analysis, privacy concerns, and in many modern smartphones there is also speech recognition present, so that with voice you can control it. Our master has 4 options which allow you to specialize towards one of 4 directions. So we have an option called Power Systems and Automation, where you learn about smart grids, power electronics, renewable energy, and also about control and optimization. An option is mostly useful if you want to become an energy specialist or an energy network operator or an energy system architect. Second option is what you could call the electronics engineer in the narrow sense, and the narrow meaning of the word, about design of chips and circuits, analog circuits, digital circuits, RF circuits, MEMS, chip design for telecom, chip design for AI, for IoT, automotive hardware, which is useful if you want to become a designer of analog, RF or digital chips, a chip and system architect, or a circuit application engineer. The third option is called ICT security and networks, and here we teach you about things like cryptography, computer security, computer networks, mobile networks, again also IoT, telecom applications and privacy. So if you take this option, you can become a security developer, security architect, network architect, telecom system integrator or service provider. And finally the fourth option, which is titled Information Systems and Signal Processing. The emphasis is on the processing of signals, which leads to machine learning, audio signal processing, video signal processing, biomedical data processing, which allows you to become an AI architect or an algorithm designer for all types of signal and data processing. On the next slide, I list some typical courses. Here in the middle are the courses that are common to the 4 options. And you see everyone learns about analog and mixed signal electronics for signal processing, about digital signal processing for communication information systems, design of digital platforms and computer architectures, and then depending on the option there are a few typical courses. The power and automation option. You have of course power electronics and smart distribution systems, electrical drives. In the electronics and chip design option, you learn more about integrated design of integrated circuits, about platforms for AI and embedded processing, and design, implementation and measurement of electronic circuits. In the option ICT security and networks, you get courses on cryptography and network security, hardware security, but also electromagnetic propagation and mobile networks. And in the option on information systems and signal processing, you get courses like image analysis and understanding, audio and speech, medical imaging analysis, and multimedia technology and coding. An important component of our courses is formed by the design seminars. First design seminar is part of the course Design of Digital Platforms, where you learn about hardware, software co-design, where you get a problem, where you will implement the first solution of the problem by writing software that runs on a small microcontroller. You will then notice that this solution is too slow, and then you will learn how to analyze your code to look for time-critical parts and implement those in hardware. And a second type of design seminar is in the Problem Solving and Design course, or P&D, where depending on the option that you choose, you will solve a different problem. So this can either be the design and really production of an analog or digital chip, or the design and implementation of a brain-computer interface to control an acoustic zoom, the design of the optimal connection to an offshore wind farm. This will be, of course, on paper and in simulation. And finally, there is also the option to design and secure a wireless instant messenger. We also leave a lot of space for elective courses, depending on the option you choose. Between 27 and 33 of the 120 credits is formed by elective courses. Between 12 and 18 points, again depending on the option, is elective courses from a list that is specific for each option, that allow you to specialize within the option, or you can also choose to take compulsory courses from one of the other 3 options, thereby broadening your knowledge a bit. You also have to take some general interest courses. This is a rule by the university that forces you to spend at least 5% of the courses on general interest courses that are non-technical. We have a long list where you can choose from, and then you fill up until 120 ECTS by taking other courses from our option, from our program, or courses from other master programs of our faculty, or courses from master programs at our university, pending approval by me, or you can take an internship, take the add-ons course, or any of those things. We are also a master program with a view to the outside world. We are heavily involved in Erasmus networks. We allow you to spend either 1 or 2 semesters or make your master thesis at another place in Europe. You can do an industrial internship abroad if you want, and this can count for 6 ECTS. We have also agreements with universities outside the Erasmus network. For example, we are a member of the Euro Scholars Network with the USA. You can find more information if you go to this website. And actually, we also try to organize a bit international experience at home. In our master program, we have many different nationalities and local students mixed together, such that wherever you come from, you learn something about the rest of the world by speaking to your student colleagues. So, to summarize a few reasons to study electrical engineering at KULeuven, our department, which is also known as the ESAT department, is top of the world in electrical engineering. We have more than 500 researchers in our department. So we're one of the largest departments of the university, and many of our researchers are experts with an international reputation in their research field, be it cryptography, be it circuit design, be it signal processing. In all these type of applications we have world top experts, and our teaching is based on the state-of-the-art research of these experts. We have a good infrastructure with student labs, PC rooms, very modern meeting places for the students, and we have a large community of local and international students from all corners of the world. If you want to know more, you can go to any of those websites, Dutch-speaking and English-speaking education, or you can mail to this email address and get more information. I thank you for your time.